Welcome to the video for lesson 7.4, more multiplication properties of exponents. Really what we're looking for is a power to a power. Okay, how do we evaluate a power to a power? So that's what the video will cover. First, some warm up and some review. All right, so here we have -9 to the 0th power. All right, any 0 power turns what it touches into a 1. Okay, so you look at what is the 0 touching, and it's touching this 9. So that's going to be turned into a 1. The negative was not affected. So the answer for this one is -1. Okay, second one, negative exponents bring their base to the bottom, and we make that positive then. So here we have x as the base. The -5 is touching the x. It's not touching the 3. Right? So the x will be moving down. The 3 will be staying put. So we have a 3 over x. Now it's a +5 in the denominator. Okay, -8 to the -2. All right, negative exponents bring down the base. Okay, the base is that parentheses -8. So that's going to be moved to the bottom of a fraction. We're gonna put that in the denominator, exactly like it was, but now a +2. There was nothing that we did not bring down, so we just put a 1 up top. And then -8 to the 2nd power is +64. Okay, then this one from yesterday, 3 and 6, those are called coefficients. So we multiply those, that's 18. But if you're multiplying powers with the same base, let me go a different color. If you're multiplying powers with the same base, so x and x, what we do with this 5 and this 3 is we add them together. So this is x to the 5 plus 3, or x to the 8. So that's just a quick recap of what we've done this week. Okay, when we're looking at a new rule then, okay, now we're looking at a power to a power. All right, so when we're looking at something like that, what we need to be able to do is just understand what an exponent does in the first place. Okay, this 2 means there's 2 of something. It means there's 2 of whatever it's touching. So there's 2 of that parentheses. In other words, there's 2 4 to the 5ths. Oops, I messed that up though. There we go. 2, it's 4 to the 5th times 4 to the 5th. And what we said yesterday is we add those exponents together. So what we really have is 4 to the 10th. Okay, but what could have been maybe faster if we would have just looked at 5 and 2, we could just multiply those together and get 10 a little bit faster. Okay, same thing here with there's 3 of whatever that exponent is touching, so there's 3x to the 4ths here. X to the 4th times x to the 4th times x to the 4th. That's really what this is saying. All right, so what we're doing is, oops, again, messed it up. What we're really doing, okay, is we're doing x to the 4 plus 4 plus 4, but that's just x to the 12th. Okay, but maybe the faster thing would have been just to say, how can I get 12 out of 4 and 3? All right, so what's really happening here is if you have a power to a power, then you are multiplying. So a to the m to the n is really just a to the m times n. Okay, this is called power to a power rule. All right, then I'm just going to add one on. I'm going to make another box. Okay, if it's a power of a product, okay, something else that we should be aware of. So if we have a b to the m, what happens is we distribute that m in. So this is a to the m times b to the m. All right, so that's going to be another rule just that's going to come into play in just a second here. Okay, let's move on and look at some examples. So it says simplify each expression, make sure not to leave any negative exponents. Okay, so here we have x to the 2 to the 5. So this is when you have 2 exponents right back to back. Okay, an exponent outside the parentheses. All we're saying today is make that x to the 2 times 5. All right, which is x to the 10. Okay. Then we get into the power of a product here right away then. So if you look at this next one, okay, this 2 on the outside is going to go to everything on the inside here. So we need this 4 to be squared. Okay, we need this x to the third to be squared, and we're going to be multiplying that x to the 3 times 2. And then we're going to do this 2 times this 7, y to the 7 times 2. Okay, so I'm just distributing that outside 2 exponent into everything on the inside. That gives me 16, x to the 6th, and y to the 14. Okay, 4 squared is 16. All right, same thing here. We're going to look at distributing this 2. Okay, we have to be careful here. Negative 3 is in the parentheses, so negative 3 squared. Okay, x to the 4 times 2. All right, and then this one, be careful as well. This is like a y to the 1. Okay, so we have y to the 1 times 2. Okay, so we distribute that 2 in, and then now we have negative 3 squared, which is positive 9, x to the 8, y to the 2. Okay, one more time like that. Distribute this 3 in. Okay, when you do negative 2 to the third, you can put that in parentheses still if you want. Okay, that's going to end up being negative this time because 3 is odd. We'll get to that. X to the 5 times 3 and y to the 3 times 3. All right, so what we end up with, negative 2 to the third is negative 8. We have x to the 15th. We have y to the 9th. And we're done. Okay, so the rule is if there's a power to a power, you multiply the 2 exponents. Okay, same thing here. You can go ahead and work through these and try them ahead of me if you like, and then click play when you're ready. I'll start talking about them as well. Just make sure, again, we don't leave any negative exponents. So this 4 is going to get multiplied by this negative 2, and then this is like an n to the 1. So we have m to the negative 2 times 4, which is negative 8. And then we have n to the 1 times 4, which is 4. And then we can't leave a negative exponent, so the m will go to the bottom, and then the negative 8 will turn to a positive 8. Okay, here, this piece out front, this 4a to the third, is just going to stay there for a second. We'll leave that alone for a second. We want to deal with parentheses and exponents first with order of operations. So we want to put this 2 to the 5, so we're going to keep the 4a to the third the same, times this 5 to the second power, that's 25. A to the 4 to the second is a to the 4 times 2, which is 8. And then this is like a b to the 1. So we have b to the 1 times 2, which is b squared. Okay, now we've dealt with that exponent on the outside. Okay, we can multiply this 4 and this 25. That's 100. And then now we have adding exponents here with the a to the third and the a to the 8th. Okay, now it's 2 of the same base, so this is like yesterday, a to the 3 plus 8, so a to the 11th. And then the b squared didn't have anything to combine with, so that one's done. Okay, next one here, we can deal with this 5 and 2. This is n to the 10, n to the 5 times 2, and then we need to distribute this 3 into everything here. So this is 4 to the third, which is 4 times 4 times 4. I'll just leave it as 4 to the third for this first step. That's going to be 64 though. M to the negative 1 times 3, that's m to the negative 3. And then we have n to the 2 times 3, which is n to the 6th. Okay, then we can combine some things. Okay, first, this 4 to the third is just 64. We have two things with n in it, n to the 10, n to the 6. That's when we add those, n to the 16. And then this m to the negative 3 right here, okay, we can bring that down and make it a positive 3. And then that one is done. Okay, this next one looks like it might be complicated at first, but really what we're looking at, okay, is I see a 0 exponent. Anything that this 0 exponent touches is going to get crossed off, turn to a 1. The 0 is touching the parentheses, so all of this turns into a 1 right away. So all we have to deal with is this 2x to the negative 6. All right, so this negative 6 can go to both of these. Okay, what ends up happening there is we get 2 to the negative 6 times x to the negative 6. Okay, they're both negative exponents, so we're going to move both of those down. okay? Where it's now 1 over 2 to the 6th, x to the 6th, and 2 to the 6th is just 64. So 1 over 64, x to the 6th. Okay, the last thing here for the video, okay, has a geometry type connection. Okay, it says a square has a side length of 6x to the 4th. Okay, that means that all of the sides are 6x to the 4th. Okay, and a rectangle has a length of 4x. Okay, what does the width of the rectangle have to be so that the square and the rectangle have the same area? All right, so this square here. Okay, the area for this one is you just take the side length and you square it. Okay, so the area of the square is just 6x to the 4th to the 2nd power. So that when we distribute that to 6 squared is 36, x to the 4 times 2 is x to the 8. So that's what we want the rectangle area to be, and that we're doing length times width for this one. So the question is, what does that width have to be? So when we're looking at that, okay, we have 36x to the 8, okay, equals 4x times, we're just going to call it w, the width. Okay, so all we need to do is just divide both sides by 4x. Okay, and then go from there. So this one would be 9. Okay, so here we would have 9 from 36 divided by 4. And then this x to the 1, this is something we'll get to soon, x to the 1 and x to the 8th. This x to the 1 will cancel. One of the 8x is up here, so it would be 9x to the 7th equals w. All right, and that's it for this video for 7-4. Thanks for watching. Let me know if there's any questions.